Here are solutions to quiz 6 for Math 251. You just had to do 2 of these 3 problems. I'll do all 3 just so you got the solutions. Basically, we're asked to find the derivative dy over dx of this equation. This thing is called the folium of Descartes, or Descartes, I guess. I don't know how to say his name. It's got some history. I won't get into the history here. All I'll do is take the derivative. So let's see, dy dx, you're supposed to treat the x's like variables and the y's like functions. So if we take the derivative of both sides of this equation, what we get is the derivative of x cubed is 3x squared. The derivative of y cubed is 3y squared times y prime. That one's a little bit tricky here. The outside function is x cubed. The inside function is y, whose derivative is y prime. So we're using the chain rule here. And then here we have to use the product rule. Maybe 3x is one of the functions and y is the other function. So we got the derivative of 3x is 3 times y, and then leave the 3x alone and take the derivative of y, which is y prime. And derivative of 0 is just 0. So you get to here. We want to solve for y prime. We got 2 y primes here, so let's get them all on the same side of the equation. Maybe we'll leave this term where it is. Add 3y to both sides, and then subtract 3x squared from both sides to get to here. Now if you factor out a y prime, you get 3y squared minus 3x equals 3y minus 3x squared. So you get y prime is equal to 3y minus 3x squared divided by 3y squared minus 3x. Which I suppose we cancel out all those 3's, factor out a 3 from the top and the bottom, cancel those, and get y minus x squared divided by y squared minus x. And we can leave this right here as our answer. Second one here, we're asked to use logarithmic differentiation to find the derivative of this mess. So instead of f of x, I'll write y equals x to the 2x. Logarithmic differentiation, there's a big hint that you have to take the log of both sides, because otherwise there's no way to take the log, or to take the derivative of x raised up to the 2x power. So why are we taking the log of both sides? Well, the log of something raised up to an exponent, you can bring that exponent down in front and rewrite using our log rules from this step to this step. And now it's in a form where we can take the derivative of both sides. The derivative of natural log of y, we're going to use the chain rule there and call it 1 over y prime. Y is a function, its derivative is y prime. On the right here, we're going to have to use the product rule. Derivative of 2x is 2. So 2 times the natural log of x plus, leave the 2x alone, the derivative of natural log of x is 1 over x. So what we get is y prime equals, we can multiply both sides by y. It's 2 natural log of x. I'll just call this 2 because the x's cancel out. But you don't want to leave it right here because we know that y is x to the 2x. So we could say y prime equals x raised up to the 2x power times 2 natural log of x plus 2. I don't know, you can rewrite this a couple ways if you want. I guess you could factor out a 2 from both of these. Maybe I'll write or 2x to the 2x times natural log of x plus 1 if you really want. Any of these are fine. I don't really care how you leave it. But there's your derivative. This third one, I think this was the hardest one, but I don't know. I guess if you were really good at Math 112, maybe it's not too bad. Evaluate the derivative of arc cosine of x using the method demonstrated in class. Okay, so what I'm going to do is I'm going to say y equals arc cosine of x, and I'm going to try to find y prime. And maybe you see how this is equivalent to answering this question here. And if you do, that's good because y equals arc cosine of x, that's the same as saying the cosine of y equals x. Algebraically, we're taking the cosine of both sides of this equation, and it cancels on the right here. So we get the cosine of y equals x. We can take the derivative of both sides. Derivative of cosine is negative sine. So we got negative sine of y, but then you're not done over here because this is chain rule. We took the derivative of the outside function, cosine of x. Now we want to take the derivative of the inside function, which is y. So we'll multiply that times y prime, and that's equal to 1. So solving for y prime, we got y prime is equal to negative 1 over sine of y. If you get to here, I'm pretty happy, but there's still a lot of work to do. Y is arc cosine of x. So from here, what we can say is y prime is equal to negative 1 over the sine of arc cosine of x. Which is good. At least now we don't have y's in our answer, they're just x's. But this is something you can simplify. This is a Math 112 problem. Tricky one in my opinion, but again, if you're really good at Math 112, maybe this isn't too bad for you. The way I do this is I change it to negative 1 over sine of maybe t. So what I'm saying here is that arc cosine of x, I just want to have a name for it, I'm going to call it t. And if arc cosine of x is equal to t, that's the exact same as saying x is equal to the cosine of t. I take the cosine of both sides of this equation. So x is the cosine of t. If I try to draw that in a picture, see, here's t right here. Here's my almost a right triangle. This is meant to be a right triangle here. Cosine, SOHCAHTOA. Cosine is adjacent over hypotenuse. So for adjacent over hypotenuse to be x, we need x over 1. So what we want to do is figure out what this is. Let's see what this, maybe I'll call it a for now. Or no, I'll call it, well, O won't look good. I want to use O for opposite, but I don't really like A because I think adjacent. Maybe I'll call it Z. Whatever. Just a name. Anyways, I want to figure out what Z is equal to in terms of x. Well, I know that x squared plus z squared equals 1. X squared plus z squared equals 1. So z squared is 1 minus x squared. In other words, z is equal to the square root of 1 minus x squared. Plus or minus really, but you don't need the plus or minus because we're talking about distance here. So z is the square root of 1 minus x squared. So let's see, what are we doing here? Our answer is negative 1 over the sine of t. So negative 1 over sine of t. I can figure out what the sine of t is now that I have this picture. Sine is opposite over hypotenuse. Here's the opposite right here. Right, so OH, yeah, over hypotenuse. So this over 1, get my final answer is negative 1 over 1 minus x squared. Kind of a lot going on there. I don't know. I guess you get some partial credit if you got to here or even to here. But kind of, this is okay, this is good, this is great. This is the final answer. That's the end of this quiz.